Hi everybody. So tonight I was going to... Buddy, come on. Stick around, partner. Come on. The adult voice comes on and... Hey, you want to make a special appearance? Come here. Come on, let's show everybody that you really exist. Come here, buddy. Get ready. Here we go. Here's Merrily. Here's Merrily in the flesh. He does exist. You want to say hello? No, you just want to do some code with Daddy? Okay, so we're going to do some code together. I was gonna actually take the evening off, but because we're rolling out a new release of Mentor tonight, and we're all kind of doing stress testing and things. But I saw something somewhat interesting that I thought I'd share with all of you, and maybe we'll make this like a weekly or a monthly thing, but this will be maybe the first coding challenge for Goju Tech Talk. And I want to show you what I was just looking at. But before I dive into that, I wanted to share that so this is our staging site where we're staging our build and testing it. But we're looking at Clickhouse, which is here real-time analytics database management system. Clickhouse is a pretty good code base in general, at least according to Mentor, and I've looked at the code at least peripherally, and yeah, it seems like it's not bad, especially for a code base that's almost 2 million lines of code. But we have this new feature now in the latest build, which allows us to see essentially the full length of some of these control expressions that Mentor finds. So before it would kind of just stop here, and so you'd see, oh yeah, there's like a lot of code, but now we can scroll. And so because we can scroll, I can actually go all the way to the end here, and you'll notice that there's one expression here that literally is twice as long as all the rest. So I was curious about this, and so I clicked on it, and it showed me this. So I wanted us to take a moment and stare at this code for a second and try to ponder what it's doing. Now, I'm going to close Slack here just so it doesn't blow up on me. Now, I just saw this code for the first time, so I have basically the same background on it that you have. That's not totally true. I was actually looking at it for about 5 minutes before hitting the record button, so I've got a 5-minute head start. So at first, when I looked at this code, I thought, wow, this is really not good. Like, this is the definition of sort of not great control expression. Massive if statement. But then when I tried to start to decompose the logic, I started to realize something, which is without hacking the preprocessor and doing something like with stringization, I'm not actually sure how I would rewrite this to essentially get the same behavior, and a lot of it has to do with the template parameters that are communicated to this template function. So if I'm understanding this correctly, what this is doing is, and again, I haven't looked at this deeply, so I don't know. So take all of this with a grain of salt. We may have to do some investigation. But my speculation is this execute number function is a template function that minimally takes 2 parameters. It's possible that there's more, and that it's allowing the compiler to then determine the 3rd or 4th parameters, whatever they are. Maybe they're default, who knows. But the first 2 are being specialized, so we're actually forcing them in. And if this if it was limited to just 2 template parameters, this would be fully specialized. But if it's more than 2 template parameters, which we don't know yet, or at least I don't think I know yet, this could be partial template specialization. But we are providing essentially these types. And what we see here for this first parameter is it's index type the whole way down, it appears. Yeah. But we notice that the function changes. So it starts and it's just execute number, but then we get to a case where it's execute const, string, and then a bunch of array numbers, and then array string, and then execute generic. And execute generic takes essentially just the index type, or I guess these last two take just the index type, and then the second parameter, which is the additional type information, at least in all the other calls, are not provided for these last two. Again, I'm figuring this out on the fly, so what my speculation is that since this is an array string, the second parameter, it kind of just thinks it knows as this string type, array string type. So it by the name of this. So it doesn't necessarily need to provide that. And then this execute generic, I don't know, but maybe it's going to try to figure this out. Okay, so we have those data. This is, we're kind of building the story for what this is doing. But then if we look at this function and we start to process this logic just in our heads, we see that it's essentially doing not of all this stuff. So we'll ignore the not for a moment and we'll start to process this. We also notice that each function call returns this value, which is a column pointer, it seems, or it's something that's cast implicitly, not explicitly. So there's minimally either it is a column pointer or it's doing an implicit typecast to a column pointer from whatever this returns. Those are sort of the two scenarios I think that exist for what could be going on. Again, without looking at the definition of execute number and these other ones. So again, at first glance, this appeared to me to be a bit silly. Like, why are you doing all these assignments? But then I just kind of went with it and said, okay, well, let's just pretend that this makes sense. And so we execute this first thing, and then it does something, and then we keep going. And I noticed that these are all ORed. Okay, so in my head then, what dawns on me is that as soon as you get a single true, the short-circuited logic will see a true ORed with anything is true, and it'll stop executing. And then I notice that the not will invert that true to be essentially false. And so if any of these return true, this then will evaluate, I think, as false, and this if condition won't be executed. It won't go inside of the if, and this exception won't be thrown. Instead, res will be returned. So then it dawned on me that this is actually relying on the short-circuited, I think, it's relying on the short-circuited behavior of this execution in precisely the way that the compiler will execute this, do the ordering for this. And then as soon as it gets the first true, so it'll go false, 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 it'll keep going, false, 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 until it gets the first true. Let's say it's on this one with decimal 32. Res is equal to true, and then it sees that this is or I'm speculating again, like this non-zero value, and then now that it's true, we basically stop the execution of all of this, and then whatever the single one that passed that does the sort of the correct conversion for this call into execute number with the right template parameters is the result that's stored, and then you return that result. And my speculation is that result is giving you essentially the type information in some sort of value that then lets the caller know this is basically the cast that he was able to do dynamically for whatever this operation is. In some sense, it's almost doing like a dynamic cast, except rather than doing a dynamic cast that's relying on inheritance, it's doing sort of this dynamic cast using templates and walking through all of the native types that it can do this casting for. So now I'm starting to get a little bit intrigued, because while I still think that this if expression is a bit abysmal, I started to realize that I'm not actually sure how I could rewrite this such that it would allow the various permutations of the template parameters without hacking the preprocessor. Now, if I wrote some macros and I did stringization, I think I could do it, and I would just create essentially some mapping of all the different types, and then I would do some stringization that basically expanded each of these into the various types, and I would make sure that I got the stringization exactly right, and then it would do the automatic generation, and it would look like one line of code, but it would really be however many lines of code this is. It would be 40 lines of code. It's approximately 40 calls. But then it dawned on me that that would shrink the code footprint, but that's not super great, in that my solution would maybe make it appear simpler, but it's actually very complex. And so then if someone wanted an additional type, they would have to understand the complex macro stringization thing that I just built, which it seems fewer and fewer people are going way down that rabbit hole these days. So then I tried to think, how could you do this without stringization? Because again, hacking the preprocessor, like, I know that those of us that are super coders, we can do it, and I've done it, but boy, if you have a bug in that, or you get something slightly wrong, this will break compilers, right? With the way the stringization happens and the code replacement. And so I try very hard to stay away from that. And I might actually prefer this, that is super big, in favor of me being able at least to understand it, than shrinking the code footprint and having this complicated stringization that like 7 people on the planet actually understand. And again, for those of you that have done massive preprocessor macro stringization stuff, I know you know what I'm talking about. And for the rest of you that haven't done it, I encourage you to Google it, and you can read about the crazy things you can do, but maybe you shouldn't do. Okay, so now if the preprocessor hack is out, it leads me to other questions of, is there another way to do this that essentially achieves the goal that these developers are appear to be trying to achieve, which is a very interesting and powerful runtime type binding that is strict type binding, it appears, which is great. And it's basically sort of doing reflection, not full reflection, but it's in some sense type discovery at runtime. And C++ doesn't natively have reflection like exists in C Sharp, at least not to the best of my knowledge, or at least not the variants of C++ that I've used heavily. So now, historically, when I would do stuff like this for these variabilities in types or things, I would just create an enum, and then the enum would be the thing that I passed in, and then I would just do a for loop for the enum, and then that would essentially get me the behavior. And it turns out that when Mentor is given this problem, this is what Mentor does, is that it basically tries to do, so it doesn't exactly do it this way, but it's making this point of, or equals these things, and it's iterating for whatever these ranges are, and it's trying to, it's like assuming that you can pass, assuming that you can determine the type information in some sort of for loop mechanism. And again, normally, for things not being done at compile time, like things that are actually in the code, you could do this. And then here, again, Mentor is struggling with this. And here, Mentor is, again, kind of struggling with this. And then here, Mentor is struggling with this. And so I was actually quite interested, because usually Mentor can handle, I was literally watching it generate an entire class system, which I'd never seen before, while it was rewriting some other control expressions, and that was a really big control expression in some other code. But for the first time in a long time, I'm seeing Mentor actually totally fail, at least in the insights part. And again, I like to keep it real here, and this is a work in progress. There's things that we're working to improve upon, and so Mentor's not always going to get it right. It's usually really good at identifying the stuff that needs to be fixed. This usually, we're seeing that if Mentor flags it, it's like, yeah, you should probably fix this code. And I don't necessarily disagree with Mentor in this case. I look at this and I think, yeah, you should probably fix this code. But what's really interesting about this particular case is Mentor's trying to fix it, and it's not figuring it out. It's actually going down the same paths that I would go down, and I don't think that works for this case, because you need to invoke the compile time code generation for these function signatures to get the precise type bindings that you need for this if. You can't, at least to my knowledge, you can't simply make a for loop for this, because that typical enum path, like maybe you could if you're still pushing it inside of the function, is what I'm saying, is that even if you do an enum which contains all these types, and then you have a for loop that then just walks them inside of the function, the parameters that are containing the information on the types is going to be minimally inside of a switch. And the switch is going to be this param, and then each case is going to be like int 8, blah, blah. So it's basically just pushing the complexity from one location to another. It's not the normal elegance that you would get when you have the enum solution, and it's like an array lookup, and you just execute this piece of code that isn't expanded behind some sort of interface. Again, if you're new to programming, this is probably not going to make sense what I'm talking about, and I apologize for that. I'm not trying to confuse people. I just don't have the 3 hours that it would take to explain all the complexity. But for the experts in the room, I would be very interested to hear what people think in a very sincere way, because I don't know. I actually think both Mentor and I are stumped, which I think is not like a super easy thing to do, just to stump both of us. Stumping me is maybe not that hard, but stumping Mentor all 4 times, I haven't seen that maybe ever. But this code, I think, has done it. So I wanted to put this out essentially as an open coding challenge of the week. And again, the rule that I have for this is no invoking the preprocessor. I know that you can solve this with stringization, and I've done similar things. And so for all of you super preprocessor folks out there that are getting super excited, like gonna write this really complex 100-line preprocessor macro stuff that's going to use stringization and then reduce this to an if statement that's a single line. No, you're not allowed to do that, at least not for the problem I'm proposing. What I'm asking is there a way to do this that essentially would reduce the code footprint? So it would be something like what Mentor's showing, which is sort of this for loop, but it doesn't push the complexity inside of the function that would reside here, which basically would just do replication of this inside of a switch. But instead, it would actually find a way to have strict type binding that's supported for dynamic execution, right? Because that's basically what this is allowing. Yet it reduces the size of the code to something that is not ridiculous. Essentially uses this sort of for loop mechanism. So that's your coding challenge for the week. And very seriously, if someone can figure this out, I would really like to hear what your solution is. And in fact, if someone figures this out in a way that I think is really novel, again, no preprocessor, I'll do a podcast specifically explaining the solution that someone's provided, because in the 5 minutes that I was looking at this, and keep in mind C++ is kind of my stomping ground, so I usually can look at code and be like, oh yeah, I know, you just rewrite it like this. In this particular case, that didn't immediately jump out at me, and so I thought I'd share this with all of you to spread the love.